Right, ladies and gentlemen. Again, good afternoon. For those who I haven't introduced myself to already, my name is Will. I'm also a student here at the Oxford Internet Institute. It gives me great pleasure to welcome Nigel Toon as our next keynote speaker. Nigel is a co-founder, chairman, and CEO of Graphcore, which is a silicon and systems-based company which developed the IPU, or Intelligence Processing Unit. In its last valuation, Graphcore came at $2.8 billion. Nigel has a long-standing background as a tech leader, business leader, entrepreneur, and engineer. And he has won numerous industry awards, including #1 on Business Insider's 100 Most Influential People Shaping British Technology. He has sat on the board of various industry and government groups and is currently a non-exec director of UCRI. And finally, he has recently written a book from which I believe this presentation takes its title. So please join me in welcoming Nigel Toon to the stage.
Sorry, I'm not Nigel. I really am sorry, but the fire alarm is going to go off if everyone is in this area, because the curtain, the fire curtain, is triggering. So it's got to be, this has got to be clear. This is already the fire alarm. Sorry.
I just did it. Well, this is going to be exciting. It's one way to get me to stop talking, I guess. So, well, thank you, everybody. As Will has said, I've recently written a book called How AI Thinks. I was prompted to do this by talking to lots of people who don't seem to understand much about AI, and no disrespect to Chloe, who I know does know a little bit about AI, but even people in government who struggle to understand the technology as well. So very much the motivation, and I'll try and give some summaries here of what the book is all about. So this year, 150 million intelligent machines are going to be delivered. Eventually, they will be more intelligent than you, many of them. They will end up starting businesses, running our large businesses. They will advise governments, even run governments. They will beat all of our major sports stars in every sporting event. We call them children. We are intelligent machines. Our brains are neural processors that process information to create knowledge, and from knowledge, we build intelligence. We build tools that allow us to improve our capability. We start as foragers, and then we learn how to control fire, and we become the dominant creatures on our planet as a result. We build engines that improve our strength, allow us to build cities and enormous structures that we couldn't build on our own, to go at massive speed, and even to fly. And now what we're doing is we built a tool that is going to augment our enormous personal intelligence. It's not going to replace us. It's not going to run out of control. It is here as a tool that will allow us to make the next step that first fire allowed us as humans to step to, that then engines allowed us to step to, and it will allow us to solve problems that are really fundamental to our life on this planet. Now, we tend to massively overestimate our conscious intelligence. Our conscious intelligence is a tiny part of our brain. And the fact that you can solve a cryptic crossword or write a critique on a Shakespearean sonnet, these are things that require our conscious brain. But to hit a tennis ball probably takes more compute. And it is completely subconscious, or should be, if we're going to be any good at tennis. The ability to, what is in effect, predict the future. Because that's what you're doing when you're hitting a tennis ball. The ball is coming at you maybe at 50 miles an hour from an amateur player. You are judging the flight of the ball, the spin, the surface reaction, how the bounce will happen, get in the right position, return the ball down the line to win the point. Studies have shown that our leading sportsmen actually have the same reaction times. They don't have any physical ability which is much, much better. What they do have is a neural diversity. A neural diversity that allows them to understand the flight of the ball a little bit better than you, to predict the behavior of that ball, to be able to work out what is the right position to be in to return the flight of the ball. I'm dyslexic. I have a neural diversity. We all have neural diversity. We think of ourselves as somehow being very similar, but all of our brains are very, very different. We work in slightly different ways. We solve problems in different ways. And we need to understand this. AI is just going to help us. It's going to help us to solve problems. So there are 3 ingredients that make AI. The first is information. And one of my heroes, Claude Shannon, he came up with this idea of a binary digit, which we call a bit. A bit is how we store digital information. Claude Shannon also came up with the fundamental theories of how we communicate information to, in his own words, transfer intelligence. It's what underpins our internet. It's what underpins our mobile networks. It's what makes the Wi-Fi work in your house. These are all based on the theories of Claude Shannon that has allowed us to share information. Semiconductors is the next fundamental piece that has made AI work. We landed on the moon because of semiconductors. Without semiconductors, we wouldn't have been able to build the flight control computers that got the capsule to the moon. That was obviously at the end of the 1960s. The first integrated circuits came in 1960 itself. You roll over in bed, you look at your mobile phone, and get all your news and amazing things. And maybe you wonder occasionally, there's a lot of technology in here. Maybe it would have filled my bedroom as a data center once upon a time. The reality is, without integrated circuits, it would have filled a data center that would cover the whole surface area of the UK. There are 4 billion phones in the world. That would cover the whole surface of the world, 1 million stories high. Semiconductors have improved in capability by over 25 billion-fold since 1960. And yet they're completely invisible. Well, until we have COVID, and suddenly everybody wants to buy a television or a new laptop computer or a new car, and they can't get hold of them. And suddenly they realize, these things might be quite important, actually. They are what power our lives, and are probably the most complicated thing we have ever built. They're certainly the most complicated thing that we manufacture. But semiconductors, and again, this is where our brains confuse us. We tend to extrapolate when we think about the future. We think, what has happened before is going to keep happening. Semiconductors are going to keep getting better, and they're not. We're already reaching the limits. We're already reaching the physical limits with semiconductors. And so although they will get better, and AI will get better, they cannot run out of control. They will not keep going forever. And the reality is, most of our great AI researchers actually don't know that. They work in software, completely distracted from the underlying hardware. They don't understand what has happened in the hardware to allow them to achieve the AI breakthroughs that they have. So then the final piece, information, semiconductors that drive computing, is the learning method that we use to create these AI approaches. We're not telling the computer what to do step by step in a program with AI. We're giving it a method so that it can learn from information to build a knowledge model from which we can extract information that shows intelligence. And I highlight some of the early innovators here: Jan LeCun, Yoshio Bengio, Jeff Hinton, Jürgen Schmidt-Huber. These are the people who have been working in this space since the 1980s. The methods have existed for nearly 50 years, and it's only now, because we have enough information and we have enough powerful semiconductors to drive the compute, that AI has started to actually work. And now this breakthrough and the pace, it's like a dam bursting. Suddenly we've seen this massive burst of innovation related to AI. And it will continue. We're just in the foothills. We are just in the foothills. Maybe we can see some of the peaks ahead, but we cannot yet fully understand how tall they really are and the real impact that this technology will have. I would think it's like fire. It's like steam engines that drive industrial revolutions. It's the same order of magnitude. ChatGPT, which suddenly burst onto the public consciousness in December and January, December of last year, January of this year, it's a minimum viable product. It's not that clever. It hallucinates. A law firm recently used ChatGPT to put together a case. It hallucinated. They were disbarred because of it. It is not yet that good. It is very one-dimensional in what it does. I would relate it to the computer gaming industry and a game like Pac-Man. Pac-Man's pretty good. You know, it's fun, it's color, it's engaging, but it's nowhere near the three-dimensional interactive games that we now play. That's where we are in this process. That gives you a sense of what is more to come. As Ray Amari said, we tend to overestimate in the short run and underestimate the effect in the long run, typically because these are driven by power law relationships. Most of what we're seeing today is a point solution. So think about Google Maps. Google Maps lets everybody have the same kind of capability as a London taxi driver who's gone through the knowledge. They can find their way seamlessly across a city to wherever they need to go to. But Uber created a system solution that turned that technology into a business that connected users with drivers to create a seamless service. Where we are with most of the AI today is point solutions that are doing interesting things. We haven't yet seen how they get applied to create system solutions that really change industry. When the electric engine came out, I thought that was the fire alarm for a second. When the electric engine came out, factories before that had all been built in very small spaces, very high buildings, because you had a steam engine that would drive wooden rods with leather belts to connect to all the different machines. Electric motors allowed the factories to spread out and to have separate motors for each of the machines, and suddenly we got the mass production manufacturing that came as a result of that. These breakthroughs have secondary effects. AI will have secondary effects that we cannot yet fully predict. So let me give you one example. Today, there are around about 25 million software developers. There's about 80 million who regularly access GitHub, so maybe it's that number, but 25 million counted as software. That's 0.4% of the human population. I would describe it as people from this great institution who, in the Middle Ages, would go to monasteries and would write Bibles. They were the cleverest people who were writing the books on vellum because paper and printing didn't exist. They were a tiny percentage of the population. Software engineers fall into the same category today. Everyone is going to become a software engineer. AI will allow you to control a computer and to get it to do what you want to do. Steve Jobs said, the computer is like a bicycle for the mind, and that is what AI is going to allow. So a biologist who's working on some new discovery doesn't need to become a programming expert, doesn't need to become a computer scientist to make those breakthroughs. There will be a framework where they can make some prompts, they can build systems, they can create reinforcement learning environments that will actually challenge to find experiments that they can go and do in the Petri dish. Everyone will become a software programmer as a result of AI. And that is probably one of the biggest changes that we're going to see. Back in the 1800s, they did a survey on jobs. The only job that has disappeared is the job of the controller of a lift. That is the only job that has disappeared with all of the technology and automation that we have subsequently produced. Jobs don't disappear. Unless they can be fully automated, those jobs will not disappear. Most jobs can't be fully automated. Most jobs can be improved. The drudgery work can be taken away. Maybe people will have to be retrained. Probably lots of people will have to be retrained, but AI gives us the route through which we can do that as well. We will see over the next 30 years massive change, but we've already lived through massive change. The internet, mobile phones, they've changed our lives, and yet we're all still here. We all still look pretty much the same. We still all go about our work in much the same way. But I do think somehow AI will have a bit more impact than being able to send messages with 128 characters in it, as somebody else has cleverly said. So this conference is about generative AI. Generative AI is actually pretty simple. It's like text prediction, very good text prediction. With a prompt, it will generate the next sequence in a language stream. It surprises us because it looks very human. If it didn't surprise us, that would be a problem. It acts like a well-educated human, but equally it makes mistakes. It's not going to come up with profound induction using that method. There are going to be other methods that come along, much more highly multimodal AI systems, and already most of the leading large language models combine generative AI and reinforcement learning and other approaches to make them much more effective. And that's what we're going to see. We're going to see much larger models, much more complex, much more multimodal, that will be able to solve much more complex problems. This idea of prompt engineering, which seems to be the vogue at the moment, and I'm sure we'll soon have programs that will be funding prompt engineers, that is going to disappear in a heartbeat. It's not the end game. Many more big breakthroughs and discoveries to come. And it's interesting with ChatGPT. As I said, it burst onto the public consciousness back in January of this year. In China, it was AlphaGo. 240 million people watched AlphaGo beat Lee Sedol at Go. It drove China to realize AI is at the root of their economic progress, and it's why China has been doubling down and pushing so hard on AI investment over the last, now, 7 years. So the first point is, when we come to think about safety and AI, do not blame the machine. It is not sentient. It is not making its own decisions. It is following a method that has been built into it by a human. It is using data that has been supplied by a human. I'm sure you're all aware, but perhaps haven't fully brought it into your conscious mind, that most of the large language models today are trained on Wikipedia. Wikipedia is edited by mostly male, mostly white, mostly American. And when I say mostly, I mean over 80%. It is biased. And that's what our large language models are trained on. Privacy, obviously, is a big issue. You know, all of these issues, weapons in particular, weapons where AI makes the decisions should just be banned. The UN has been looking at this for nearly 10 years now, and the Americans in particular have said, well, there might be some benefit in that. And it so far hasn't been brought through that that is something that UN mandates. I propose a very simple framework. Are we aware that we're working with AI? Are we aware of the issues that it may introduce in terms of bias and other issues? It may be persuading us. Do we understand how those issues might manifest? Are we informed to know how those issues may manifest themselves? You know, the way in which it might try to persuade us to do things that cause us to vote for the wrong political party, for example. And how do we protect the users from that? We cannot build into the machine all of the techniques that are going to allow us to do that. Certainly we can build some that will help, but ultimately we're going to rely on the AI developers, and we're going to rely on the people who are deploying these systems. And unfortunately, I think as Chloe already highlighted, governments are behind the curve on this. They don't have the experts that really understand this. And the risk is when you have AI technology leaders throwing their hands up and saying, regulate me, regulate me. Why are they doing that? Because what's going to happen is very quickly the government will say, well, that's a good idea. Who can we get to help on this? And they'll turn to those exact same AI leaders and say, well, how do we do that regulation? And we'll end up with enforcing the current leadership, the current companies, and we'll cut off development in this space. If we don't get the right balance between innovation and regulation, we won't create the right kind of Trumpian creative destruction environment that will allow innovation to prosper. And in particular, UK and Europe could miss out. Big time. The risk of singularity is overstated. Where does this concept of singularity, where machines will all run out of control, come from? It comes from a paper written by actually a scientist who worked at Bletchley Park, created some of the main breakthroughs in code breaking. He then went off to work at a university just down the road from the CIA, rather interestingly. He was an advisor to Stanley Kubrick on 2001: A Space Odyssey. He helped to describe what the HAL 9000 computer is, and for any of you who've seen that movie will know this is a sentient computer that ends up taking over. It's not going to happen. It's certainly not going to happen with silicon-based computers. I'm very clear of that. They won't be able to design themselves and improve themselves and end up taking over. They will be able to be misled. They will be able to have people misuse the technology. So the regulation has to be on the developers, has to be on the people deploying the technology. I apologize. I sort of did a bit of a pastiche of our Is Great advertising campaign, and really for effect here. So imagine a country that doesn't have any internet giants, where its stock exchange doesn't have any trillion-dollar tech companies. Imagine what that would be like. Imagine the impact that that would have on the economic growth of that country over the last 10, 20 years. Well, that's Britain. Actually, that's most of Europe. And the risk is AI is going to be much more impactful, is going to have a much bigger economic impact. And we all perhaps know now about China's long century of humiliation that they now say they're trying to break out of and recover from, where they missed out on the Industrial Revolution and were the world's largest economy and fell behind. The risk is that Europe ends up going into a long century of humiliation because we don't adopt and drive AI. It's the biggest existential risk of AI is that we don't grab hold of it, we don't invest in it, that we don't apply it, and that we don't drive our economic improvement through it. So, those are some of the themes that I write in my book. Unfortunately, it's not out yet. The publishing industry seems to be still stuck in the 1600s. in terms of how long it takes things to come out, but people who've read it have given it some very good reviews, and it comes out on February 8th. You can, of course, take a picture of this, find it on the internet, and pre-order. I would appreciate that immensely. Thank you very much.
Right, we'll now take 10 or so minutes for some questions. If you can raise your hand high so we can have the... Okay, perfectly, we're doing that. Gentlemen at the front here, please, and then we'll come to you in the back.
Thank you. Hi, Nigel. Andrew Gore. Yeah, I want to probe into your bit about semiconductors. You said that we're reaching the limit of it. So what about quantum computing and sort of stuff like that? So rather than the bytes, you know, you've got the quantum. So isn't that going to be the next wave, or keep that trajectory going, which is going to give the power behind AI?
Yeah, I think quantum will help. Quantum is not a full computer. It's very difficult to do memory in a quantum computer, for example, and memory, as we would know from our own minds, is very important. Communicate is interesting. Communication is just a time-shifted form of memory. Moves memory from one place to another, allows you to store it and use it again later. So I don't think quantum will help, but it will be mixtures of semiconductor computers and quantum computers that work together to improve. Still not clear that all the problems will ever be fully solved. Maybe there are physicists here who have a better view of that than I. Of all the physicists I talk to, I hear two different views of where we will get to and how long it will take. But I think it's one of those things that, for example, all the big hyperscalers today have huge investments into quantum, because if it ever does work, it will make a big difference. So yes, my own personal view is ultimately what we will need is molecular. That would be an area of molecular computing. It's probably a long way off, but the idea that you would build computers actually grow computers using molecular approaches, would allow us to build computers. So for example, your brain, you have GPT-3 has about 175 billion parameters. Your brain has 100 trillion parameters. The computer that would run ChatGPT would probably consume a few megawatts. Your brain consumes about 20 watts. We're talking thousands, many orders of magnitude different in capability. We will never get there with semiconductors just because of the inherent power that semiconductors require. Quantum doesn't solve that problem. Molecular might. So molecular might allow you to build a machine that was small enough that you could actually carry it around with you. At the moment, we don't need to carry it around because you have your mobile phone in your pocket and you can access intelligence in the cloud. Cloud will probably need to be powered by fusion-based nuclear reactors that AI will help us build.
Thank you. The gentleman over there.
Hi, thank you for your really interesting talk. Just on your slide about Britain and Europe and not having those big tech companies, what kind of policies do you think we could have in place? Or is it a policy problem? Is it an education problem? Why do you think that is, and what can we do differently the next 20 years?
That's a really hard question, isn't it? If you look at, why Google? One of the investors in our company is Andy Bechtolsheim, who was a founder of Sun. Built big businesses, sat on the porch of the Stanford professor with a couple of PhD students describing their project to him, and he said, "So what are you calling this thing?" And they said, "Well, we're sort of calling it Google." So he wrote Google Inc. on the check, which is the first money that went into Google. It's that recycling of people who understand the technology, who then invest, and then Andy, calls up Sequoia Capital and says, "Hey, there's this really interesting company," having written his own check, it's slightly self-serving, but all good. It calls up Sequoia and says, you should invest in this company. It's really interesting. And then Sequoia pulls in Eric Schmidt to run it. He's the adult in the room running the things. So, there's an ecosystem that causes that company to turn from a science project into one of the world's largest companies. Apple's story is somewhat similar. So it's about that ecosystem that creates. I'm not sure there is a government policy that could mandate that. You have to build that ecosystem. And London has been doing a good job of that, building that. The risk is that the current economic cycle is going to cause many of the unicorns that the UK government currently trumpets about actually not to be unicorns anymore. And that's the risk. Our pension funds invest 60%, your pension fund invests 60% in property. It doesn't invest in equity. Certainly doesn't invest in private equity. That's a legislation change that the UK government could make. One at the back over here.
Hi, thank you for that. It's Zine from ADSP. It's just a quick question. I'm in complete agreement with you. I'm a big, huge AI optimist in terms of the potential that it's going to bring in both the medium and long term. I think the one thing that maybe you overlooked is the potential short-term consequences of the deployment of AI and generative AI. I think you mentioned that no jobs have truly been displaced apart from the guy in the lift. However, we're working on technology now that potentially is going to replace 40-50% of call center jobs, for example. Okay, so I think that in order for us to achieve that medium to long-term, goal of the next day, what things do we need to do in the short term, both private sector and government, to make sure that the short-term negative impacts are mitigated?
Yeah, I think education systems need to change, and AI kind of pushes this, doesn't it? It needs to change from the 3 R's. Reading, writing, and arithmetic, and I always thought that was a bit strange that, arithmetic starts with an R. Even I'm dyslexic, I can see that's wrong. To the 3 C's. We need to teach our young people and everybody throughout their life about creativity, curiosity, and critical thinking. Those are the 3 elements of education that we really need to focus on for everyone, and that needs to be available to everyone throughout their life, because if people are curious and they're creative and they can critically analyze, then they can learn, and they can learn on their own. And AI allows people to go back to education without being embarrassed by being the old fart in the room, not understanding something. They can go online and they can learn online, and come up to speed on things. So I think we've got to create an education system that's much more inclusive and much more focused on those kind of outcomes rather than training people for skills, which we always talk about. And I do think that's wrong, because the skills are going to very quickly be obsolete.
Hello. Thank you very much for being here today. So my question is around AGI. Because there is a lot of noise around AGI today, and Sam Altman says it's going to be possible in 2 to 5 years. Jeff Hinton, whom you reference here, says that there is a danger that AI will take over. So I wanted to hear your thoughts about if AGI is feasible at all, and in connection to this, why did you choose the word think for your book?
I use think to really be provocative, because I don't actually think AI thinks. But it thinks in a way that is different from the way humans think. And yet, in some ways, it thinks the same as us. It's ultimately, there is no reason why we couldn't build neural networks that match the complexity of the neural networks in our brains. Today's computers probably hold us back from being able to do that. But ultimately, maybe we can do that. I think your point about AGI is really interesting. Artificial general intelligence. We don't have doctors who are experts in car mechanics. Maybe there are a few rare individuals that can do that. When you extrapolate beyond your current knowledge, that's when you get things wrong. The best way to do it is to interpolate, to have some grounding in certain areas of knowledge, and then you see a new situation and you kind of approximate from those those old things that you know, what this new thing could be. That's what most professors do, that's what most scientists do, it's what most engineers do. Most successful people are interpolating based on the knowledge that they built up in a particular field. So I think this idea that we will have a general intelligence that will do anything, number one, commercially, it probably doesn't make a lot of sense other than for being a star in a movie. What we need are artificial intelligences that are good at language, are good at creativity, are good at different, and maybe some of those things get mixed together and it looks a bit like a general intelligence because you've got a bit of multimodal capability going on, but it will be an approximation of what we might describe as being general intelligence with sentient thought and the ability, because most of that is actually driven by our emotions. Most of it is driven by our need to survive, which obviously in AI has no need to survive. And it's much more like imagine the situation about, if I get the dates right, about 12,000 years ago when the first person brought a wolf into the cave. And they said, I've got this wolf and it's going to help me hunt. And people are saying, oh, it's going to take my job. Oh, it's going to eat me. It's going to eat all our food. You know, AI is in exactly the same camp as that today. It's a tool that will help us. It's for us to guide it and to control it. So I think it's a difficult area to get into, and definitely that's where regulation will help us to constrain what AI can do and how it does it and the outcomes that it produces. You know, I think actually OpenAI did an incredible job with ChatGPT to build in feedback and controls, but then people still go and try and jailbreak it to get it to tell them how to make a bomb, for example. So, you know, these risks exist.
Hello, good afternoon. I'm just interested a bit in your work at Graphcore and how you've responded to the great generative AI boom, and how are you going to forge a place for yourself amongst the giants like NVIDIA and so on?
Yeah, it's a challenge, right? You know, and it's probably a story of UK tech in many ways. We're probably an outlier. We've raised $700 million, which sounds a lot, but you know, we probably need more. It's interesting, isn't it? You know, you look at what they do in the US. Department of Energy runs national labs across the US, like Lawrence Livermore Lab and, you know, all of these places. They have contracts with Intel, with AMD, with NVIDIA, that pay them $100 or more million to support their next generation chip development. So they become a customer, a first customer for those next generation chips. It's effectively state subsidy that the US government is engaged in. You know, we don't have anything similar in Europe. We certainly don't have anything similar in the UK. So whether that's the right thing, whether that's the thing that we should be doing, I think you could debate. You know, it depends whether you're a Hayek or Keynesian economist, I guess. But the key thing is that we need to have an environment that allows these companies to exist, to be funded, to grow, to be supported, because this scale-up stage is the most difficult stage for all these companies. And as you say, you know, you're competing against giants. And how do you do that? You know, you end up having two choices. Either you make enough progress with customers where you deliver enough value and you get pulled through, or you end up combining with one of the other bigger players. To build the scale. You know, we're very focused on building the technology, working with some big customers and creating that breakthrough event, but it's challenging. It's really hard.
Unfortunately, we only have time for one more question, and because we do love our online audience, we will be passing it over to them.
Thank you. So yeah, we have a comment and question by Joel Miller. Excellent talk, thanks. Jensen Huang suggests AI compute will be 1,000 times more powerful in 10 years. What specifically or perhaps fundamentally makes you very confident there is no AI control problem when we are so near the start of this wave?
So if I heard the question right, I didn't quite hear, but Jensen Huang, my friend Jensen Huang, says that AI compute will be 1,000 times more powerful in 5 years or something. Yeah, I've heard that statement. So, again, I'll try not to get too techie. When AI started back in the most recent wave of AI started, most of the researchers were using what's called 64-bit floating point arithmetic. Then they realized, oh, we can use GPUs that only have 32-bit, and that improves. And then NVIDIA came out with 16-bit floating point. We developed 8-bit floating point for AI. So you think 64 to 8, so that's an 8 times improvement. No. It's a power law. 64 times improvement in the compute capability, just by changing the compute functions. But you can't go much further than 8 bits. So maybe we can use 4 bits for storage formats. But the 100-fold improvement that we've seen is largely due to the improvement in the arithmetic formats. Second improvement has been power consumption. So time was you would buy a GPU and it would have 100 or 200 watts of power. Latest NVIDIA GPU is 750 watts of power per GPU. The next one will be 1.5 kilowatts. So the power's going up, which gives you more compute. The third dimension has been combine them together. So we used to build AI on one GPU. ChatGPT today runs on 48 GPUs. Just to run it, just to inference it, to actually train it is thousands of GPUs connected together to do that. So can we make bigger computers? Can we make more powerful? Can we get 100-fold, maybe even 1,000-fold? Yes, we probably can. But it's flattening. It's not going to keep going in the same extrapolation way. And my friend Jensen Huang, who actually sold my last company to, does have a tendency to exaggerate.